Brick Breaker Part 3, guys. I'm recording, so keep it down. Shh. Let's see. So we have a file that holds in a paddle object or a paddle structure. We have a file that also has the ball structure inside of it. And basically all they are doing is taking on all the properties of SFML, but creating a box 2D body that will go into the world and have all the shape and size and position where it needs to go. Okay? And then we talk to those structures with our main. We update the position every frame, we draw them, and the physics runs behind the scenes for us. And the SFML gets updated every time by a draw. So we have some physics, actual physics bouncing, but we ran into this problem. If we hit the paddle with the ball, because we've created these things called elastic collisions in physics, we're actually adding energy into our system, which is adding speed into our system. And that is a very unphysical thing to do. So today, we'll limit the speed of our ball. So it always goes the same speed, even if it hits. We might run into a few issues, like the paddle will overtake the ball, maybe, if it's too fast. But there will be some trade-offs. So let's go into our update position command and just write in some code that will always limit our speed. So we have set our speed. I believe it was set when we made the ball. We set it to have a velocity of 200 in the x and 200 in the y. So, what is that speed overall? Do you guys know how to figure out speed if you know the x and the y component of your speed? You ever do this in physics class or a math class? Let's say I know it's going, this is a terrible drawing, but let's say I know it's going 200 meters per second or pixels per second in that direction, and I know it's going 200 pixels in that direction, then I can say that it's actually going like this. I know because this is 200 and 200 that this must be a 45-degree angle, right? And its actual overall speed is just 200 squared plus 200 squared square rooted. Does that make sense? So that's how fast it's starting. That's its kind of scalar speed, not its vector speed. I know its vector speed is 200 in the x, 200 in the y. But I want to figure out what its scalar speed is. Yeah?
Is that supposed to be a right angle?
Yeah, it's a right angle. 200 squared plus 200 squared. Square rooted. Its actual speed is 282.8. Okay? So let's limit its speed for now to 282.8, but we can make a variable later if we want. Okay, so we're in our update position command for our ball, our function for updating position. And if you didn't know, or if you didn't use this in assignment 2, there's a limit velocity function that you could have used, and it reads the following. Function that keeps the angle of the block but limits its speed. So that's going to be useful for us. I'm just going to steal that code. All it does is find out like how fast or what direction the ball is going in and sends it in that direction, but with the speed you specify. So I'm just going to copy that code in here under my update position. I'll keep that as, I don't have a B anymore. I actually have a body because I'm keeping track of my own body. That's the only variable my structure has right now. And so here I would just write body. And then I don't have a speed as well because in the function you actually pass it a number or a variable, float. So just for now, I'm going to write 282 point whatever, 84. Is that what I said? Later on I can set that to something better, but I'll write a little to-do statement. Make a variable for speed. Make a variable for speed. So you can always, maybe your ball gets a little faster. Well, right now it can only ever go 282.84, but if that's a variable, then later on I can change it. So hopefully Those two lines of code will limit the speed but keep the angle. So if I hit the paddle with my ball, it should just bounce it off but not give it energy. Hopefully. And maybe oh, did it do it? It's hard to no, it didn't work, did it? Okay. I actually got something messed up in here that I want to fix. So let me think about it for a second. I get the velocity of the thing, right? It's weird that it doesn't work. I thought for sure that would give me what I need. Hold on, I'm gonna pause my stream. Sorry, for some reason ball is not attached to my project, so every time I do code in it, I have to save it. So if I could go file, add file, for some reason my ball has not been added to my project. It's running it, but it's not actually saving it. So that actually is limiting the velocity. It was working all along. Let's see what happens here. Bonk. Let me see if I can smack it along the side. There you go. So it does limit it. That's good news for us. Good. You could probably not constantly be checking this and only check it during a collision. That might be the way to do it. Let's check for collision. Okay, in our update position command. Yes. If we could do a couple things. We can check if it hits a paddle. We can also check if it hits any other object. That code for collision is inside of physics.h. There's collision here. Check collision right there. We could steal that. Maybe we'll steal that. Let's do it. The only problem is we are going to, ball is going to have to know what a paddle is because we're going to check if it hits a paddle, right? Makes sense. So I'm going to write include paddle.h here. But I'm going to run into an issue where ball is declaring paddle. Paddle might declare ball. We might get into a circular loop where they all start declaring each other over and over and over again. Let's see what happens if I run this. Will it run? Yes, redefinition of structure paddle. So I've already run into an issue here where paddle has been made twice in my code because when I write the word include paddle, it actually adds it to the top of my code. So if ball includes paddle and then paddle is included here, it gets included twice and C++ complains. And so the quick way around that is whenever you make your own file, and you'll see it at the top of my physics file, I write this thing called a header guard, and it protects my files from getting called more than once. Okay? So I'm going to do that, and then you can see here at the bottom this end if thing. It only runs the code if this file's never been included before. That's what this if and define. If this word has been defined, define it, and then run all this code. Otherwise, don't. So I'm going to do that with my ball code and my paddle code to be safe. I'm going to write hashtag if not defined, and then I'll just come up with any word. I like to use all capitals because we don't use those in I don't want it to be a variable or anything. I just write ball h. Okay. You can see that by default it made me this hashtag end if, so I'll put that at the bottom of my file. This is more of an advanced C++ idea, but good that we've run into it. And so here I'm going to define just that word, paddle or ball H underscore. So it's going to look, if this has ever been defined before, don't call this code. It knows, basically protect it to be included only once. So I'm going to do that with my paddle as well. All right, okay, so I'm going to write if not defined, if n def. Then I'm going to give it the word paddle underscore H, because I know I'll never use that word in my code anywhere else. So I'm going to put that at the bottom of my code so that it's all wrapped inside of this end if. And then I'm just going to define the word paddle dot H, or paddle underscore H. Those are called header guards. Because header is like the .h file, it stands for a header file, and a guard is a guard against getting it called twice. If I run that, it should not give me that error. Good, so it works. So paddle and ball now know about each other, and vice versa. That's good news, right? Or else I could come in here and try to figure out the order. If I say, okay, well, ball includes paddle, then I don't need this line, and I won't put that line in there. But then let's say paddle needs ball. How do I know which one comes the chicken before the egg? So I just protect them all. I let them call each other. We're good to go. So ball now knows about paddle. Paddle now knows about ball. Okay. So let's make a command in our ball code that knows when it's hitting a paddle. So let's go here and maybe say, we'll make it a Boolean variable. It's true or false. Check collision between ball and paddle. Great. So I'm just going to call it bool, and I'll say check paddle collision. It's something I'll want to be checking every frame when I run my game. Okay. And right now I'm in the ball code, so it's going to have to check. I'm going to have to pass it a paddle to check. So I'll just call it P1, or P, I guess. So that's a function that's going to take in a paddle variable, and it's going to return true if it hits and false if it doesn't. So there's lots of ways to see if things hit. In SFML, you just check if their shapes are overlapping. In the physics world, which is the best world we can look at for collision, we just look in physics.h and see how that program finds out if two things are hitting. So I'm going to go to check collision here between two objects. Check function that checks the collision between two blocks. So I'm just going to copy all this code. Copy. Yes. And I'm going to paste it in my ball code here. It's just a for loop. It does some box2D stuff. Apparently it checks all the edges in the contact list, so I guess it must make some sort of contact list to figure out where everything's touching. And then it just sees if they're touching. If it does, it returns true. If it doesn't, it returns false. So in this code I had a B1 and a B2, but that's going to change. Because I have two physics bodies, but one is body. That's my ball's body. Okay. And the B2 was the other body I was checking. That's my paddle's body. So I'm going to hit P1 P dot body. Does that make sense? Or maybe it needs an arrow. Does it need an arrow? No, it doesn't. It's fine. I have a warning. Oh, I got a weird dash here. I don't like that. For some reason, I typed that in. Okay, so the ball now has a command that can tell if it's hitting a paddle. Let's test it out, see if it works. So again, I just replaced this B1, because in the original function, it was block B1, block B2, but now I have my ball body and my paddle body. I'm going to keep track of that. Let's run that command. So B1 update position. It returns a Boolean, so I got to use a cout. I'm going to write B1 dot check paddle collision. It's looking for a paddle variable. I have one. I made it. It's called P1. Okay, so I'm going to write P1 in here and see if it prints 1 when they hit and 0 when they don't. ENDL. I want to get rid of any other C-outs that I might have had so that there's no confusion. Did I put one in here? No, I got rid of it. So let's it's printing 0, printing 0. Hopefully it says 1 when it hits. You think it will? Oh, I saw a little mini 1 there. Let's try it again. Slow it down, maybe. You can stop your program by like dragging in it, because that's an event. That will stop the event while loop. It's about to hit. See that? See that little 1 over there? It knew it hit for 1 frame. Perfect. So we now know we're hitting. Okay, let's leave that for today and put it. And tomorrow we'll, since we now know that we're hitting, tomorrow what we'll do is, when we do get a hit, we'll try to bounce the ball to the right if it hits the right side of the paddle, and the left if it hits the left side. If you want to try that today on your own, try it. You'll just have to figure out, you'll have to go into your check collision here. Instead of returning true, you'll have to actually physically change the direction that the ball is pointing depending on where it hits on the paddle. So you'll need to know the paddle's position, and you can get all that. Right? You could actually come in here and say, not only return true, but before I return true, like find out the paddle's check position, right? Doesn't auto type with the letter P. It needs more than 1 letter, that's why. So if I write P1 and P1 maybe, that will, P1 dot, it doesn't auto type. I'll have to figure out why tomorrow. But that's all we're gonna do today. We now know that they're hitting, we're good to go.